Okay, people, got to switch it up when you're looking at 3 by 3s. This is systems of equations that we're solving. There's x, y, and z, so we have to solve for all three of them. The process is more involved, but it's not necessary. It's not more difficult. It's not any different. You just need more steps. So don't give up. It's exactly the same stuff. You just need to persevere through it. Okay. So we do like we would normally, and we decide which variable to get rid of first. But instead of first between x and y, we're saying first between x, y, and z. Now I'll point one thing out that is one thing that I'll kind of tend to look for. If there's something like this pairing right here, where you've got a y and a negative y, by themselves, we can just add these two equations. And I numbered my equations so that, especially when I'm instructing, so I can talk about equations 1, 2, and 3. I also will make sure that you understand we need to create equations 4 and 5. Okay? If you don't create an equation 4 and 5, then you don't understand what you're supposed to be doing. Key thing is to understand 4 and 5, and there's something specific. You're eliminating a variable. The same variable. It has to be the same variable. Okay? If you don't eliminate the same variable in both cases, then you don't understand it and you're going to get it wrong. Okay? So, let me just show you. This indicates that the easiest variable to get rid of is y. So when we talk about the same variable, in this case, we are going to get rid of y. And I would recommend write that variable right here. Get used to it. Okay, here and here. And in fact, maybe just you're eliminating y in both cases. So this equation here, equation 4, is going to have an x and a z, and equation 5 is going to have an x and a z with no y. Okay? Now we'll do that with the first step here. We saw this. This is why we chose y to eliminate, because we don't have to do anything to equations 1 and 2. We just add them together. And look what happens. So we're connecting these two guys together. I'm going to even write them out. 2x plus y minus 3z equals negative 12. Because often you're going to have to do something when you transfer the equations here. I'm just writing them as is. 5x minus y, those will go away, plus 1z, if we want to talk about it like that, equals 11. So the equation then becomes 7x. This goes away, otherwise we've done something wrong. Minus 2z equals 1. And I'm going to ask you to rewrite this equation, because usually you're going to have space, and you big writers, you got to learn to be a small writer here with the space that we've given you, or just get a separate sheet of paper, because some of you have big writing. All that is equation 4. We have to do the same thing to get an equation 5. But what we have to recognize is if we used equations 1 and 2, we have to incorporate equation 3 this time. And we still have to focus on eliminating y. So we've got a 3y. And we have our choice of either equation 1 or 2 to combine with equation 3. Okay, with the intent of, and I keep pointing at the y's, with the intent of getting rid of y. And that's our only focus right now. Okay, now, some of you may already have in your brain that this would be the one to utilize. I would think the same thing, because this is already a minus. This is already a minus. All we need to do then is multiply this equation by 3, because that'll turn this negative y into a negative 3y, which could then combine with a positive 3y. So when we move our equations down here, we're doing something in the process. Distribute that 3 throughout. Okay? So that gives me a 15x minus 3y plus 3z equals 33. And then the last equation we don't have to alter, because that 3y and that 3y are now going to cancel. So we're just putting x plus 3y minus 2z equals negative 13. And we're going to draw a line underneath. This is a 16x, because there's a 1 there, right? That goes away, as we had hoped. Plus z equals 20. Now, again, our equation, in some cases, if there was like a 2z here, I would suggest, or all even, divide by 2, make your equation 5 a little easier. And technically, you don't have to really rewrite it. You have your equation 5. It's 16 plus 1z equals 20. Those are your two equations that you're now going to combine together in this space to solve for your first variable. Okay? So this space here is the new workspace. And I think we can all sort of agree there's an obvious choice for the easiest one to eliminate, and that is the z. Okay, we don't want to try and make 7 and 16 the same. We've got a negative 2z and a positive 1z. We have to multiply which equation by what? That's right, equation 5 by 2. That'll make that a 2z, and that negative 2z will combine together and go away. So equation 4 is 7x minus 2z equals 1. Didn't have to do anything to it. When I distribute the 2, I've got a 32x plus 2z equals 40 after I've distributed. Oh, look at this. I just caught something. Let's go back. That should be a negative 1. That should be a negative 1. And therefore, this should be a negative 1. So when I combine these together, I have a 39x. Those go away equals 39. I panicked for a moment, but I caught it in the midst of my explanation. So that's how easy it is for this thing to blow up in your face. So just be aware of that. I knew this worked out evenly, so when I saw the 41 and the 39, I knew something had to go south, that probably needed to be a negative 1, and I caught it back here by looking back there. Something you can do by yourself, and I would encourage you to do so. 39, divide by 39, you get x is equal to 1. Okay? You get x equals 1. Now you can go back to either 4 or 5. You cannot go back to 1, 2, or 3 yet. Okay? You go back to equation 4 or 5, and I think probably 5 because they're all positive numbers, and you got z already by itself. So plug 1 into the x here. Okay? So you got 16 times 1 plus z equals 20. Well, that's easy enough. That's 16. Subtract 16 from both sides, you find that z is equal to 4. Okay, running out of lead on my pencil, this is taking so long. Z equals 4, x equals 1. Now we have enough information to go back to the original 1, 2, or 3, plug 1 in for x, 4 in for z, and find our y. And I think equation 1 is probably the best because it has a y by itself. If we're solving for y, you could solve for any of these, but y is already set. So we're going to go back. We're going to say 2 times 1, which is our x value, plus y, which is what we're solving for, minus 3 times 4 equals negative 12. Okay? 2 minus 12. So 2 minus 12 is a negative 10. Okay? Equals negative 12. And the last thing we got to do is add 10 to both sides. I get a y is equal to negative 2. Okay, you'll notice I have an x, I have a y, and I have a z. Your answer should be, oh, here it is. Your x value is 1, your y value is negative 2, and your z value is 4.